Welcome to the Vhdl Design and Modeling of Digital Systems course, Aliases. Vhdl has aliases. If you've written in C, you're very familiar with define statements. Aliases here are used to do the same thing. We use it to make code clearer, more portable, and also maintainable. The most straightforward version of the alias syntax is the simplified version, which is defined here as alias identifier is name. One of the things we're looking to do when we're using aliases is basically to use shorter versions and more descriptive versions of a longer string. Here's a couple examples. Alias ALU data width is aliased to work.alu types.data width. So instead of having to make reference to work.alu types data width, all we have to do is refer to it as ALU data width, and likewise the second one. Alias IO data width is work.io types.data width. Instead of having to refer to it as work.io types.data width, we simply refer to it as IO data width. The extended form syntax is similar to the simple form. Alias, identifier, and then an optional colon subtype indication is name. Here's a couple of examples. The first one, alias interrupt level colon bit vector 4 down to 0 is PSW 30 down to 26. Here, where we're referencing, say, interrupt level parenthesis 4, that would correspond to PSW 30. And interrupt level parenthesis 3 would correspond to PSW 29, so on and so forth. We can also use aliases for changing direction of a vector. In the second example, we have a signal definition. Signal bus A, standard logic vector 7 down to 0. Then we alias a bit reversed version of the same signal, bus A, by saying bit rev A, as in reverse. Standard logic vector 0 to 7, which is in the opposite direction, is bus A. So that way we can use an alias to refer to bus A, but defined in the reverse direction. The extended form syntax of an alias declaration is as follows. Alias, which is followed by identifier or character literal or operator symbol, is name, and followed by bracket signature end bracket. We'll talk more about that later. Here are a few examples. The first one is alias binary string is bit vector. Here we're basically substituting one character literal for a different one, so that we can refer to a binary string. We can refer to a bit vector as a binary string. The second example, here we define a type, user-defined data type as system status, enumerated as being either idle or active or overloaded. Then we define an alias as being status type, and we will substitute the string or identifier work.systemtypes.system status. The next example here, what we're basically doing is defining as in for a package declaration. A couple of procedures, or the interface too, both have the same name, increment, and they are being overloaded. The first one has BV as defined as in-out is a bit vector, and it has another input BY, and that's defined as integer, and it's pre-initialized to 1. And the second procedure is also called increment, but it has an integer defined as int, also in-out, with the same parameters as well. The two aliases here, we are able to define BV increment and int increment based on if the parameters passed to it are bit vector and integer, or integer and integer. In the last example, we're basically providing an alias for the multiply symbol, or the splat sign, if you will, plus and minus, and they're defined respectively as and, or not. And is passed, both operands are a bit, and it returns a bit, and the not is defined as a parameter passed to it as bit and return bit. Notice the brackets around our parameters, and what it returns is what we refer to as signature.